All right, review for test number 6. So I'm gonna try to keep this within an hour. All right, number 1. So we want to graph each function. And these are the 3 different forms that you'll see. So first off, all right, so the first one is in intercept form, right? These tells us where the graph crosses the x axis. So intercept form. It opens down. How do I know? Because the a term is negative, right? It opens down. Again, because it's negative in front. All right. The axis is symmetry. All right. It's going to be a vertical line. X equals, we have to figure out what number. So it's going to be, so if we look at the x intercepts, inside lies. So x equals -5. X equals -1. All right. It's the opposite of what was up here. And it's going to be the axis of symmetry, that is exactly in the middle. It's exactly in the middle. So somewhere on this dotted line is going to be the vertex. So that axis of symmetry, the dotted line, x equals -3, right? It's spaced exactly in the middle of the x-intercepts. So now we have to figure out where on that dotted line is the vertex. Okay, so this p plus q business, that's just the x-intercepts, right? It's midway. We've actually already figured it out, right? It's x equals -3. That's, I mean, visually, you can see that the axis of symmetry has to be in the middle. That's what this p plus q business is. All right, the vertex, however, we're going to plug in -3 to figure that out. So -2, -3 plus 5, -3 plus 1. All right, we're just plugging in the axis of symmetry to see where on the axis of symmetry is the vertex. So this is going to be -2, -3 plus 5, 2, -3 plus 1, -2. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Negative, negative, make it positive. So this is equal to +8. So when x is equal to -3, right, because that's the x component of the vertex is also the axis of symmetry, the y value is going to be +8. So -3, +8. All right. The dilation is going to be the a value, right? This is -2, right? It's scaled by a factor of 2. The y-intercept, where does it cross the y-intercept? That's the next question. So when x is equal to 0, right? When x is equal to 0, that's the y-intercept, right? This is when x is equal to 0. So we plug in 0. So -2, 0 plus 5, 0 plus 1. This is going to be -2 times 5 times 1, which is -10. Y-intercept is at -10. Y equals -10, right? Y equals. So at -10, it's down here. Which we now know that that can get reflected across the axis of symmetry. So there my, I mean, we're actually pretty good to go ahead and just start connecting the dots. I mean, we're looking for accuracy, not necessarily precision. Okay. X-intercepts, we already said, was -1 and -5. Right, x equals -1 and -5. The domain, all real numbers. Right, the domain of any quadratic is all real numbers. And the range is going to go from the vertex towards one of the infinities. So this is going to start at 8, right? The range is going to start at 8 and go down. So down is towards negative infinity. So that's what we're going to put first. Negative infinity up to 8. And we're going to put a bracket because it's included. And this has a max. Right? It has a max because it opens down. Okay. That was intercept form. All right, looking at the second one. This is in standard form. It opens up. How do I know? Because the number in front is positive. The number in front of x squared is positive. All right, axis of symmetry. This one is not easily identifiable. Right, the only thing that's identifiable from looking at this is 1, it opens up because that's positive, and 2, it crosses the y axis at -15. Those are the two things that we can 100% say just from looking. But since we're going down the list, axis of symmetry, that's the next natural thing to find. This is going to be negative b over 2a. So in this case, b is equal to -2, and then a is equal to 1. So plugging that in, we get -2 over 2 times a. So negative times negative is a positive. 2 over 2, which is 1. So x is equal to 1 is going to be the axis of symmetry. Change to blue. I don't know why I did that. All right, axis of symmetry. Well, x equals 1. All right. Somewhere on here is the vertex. So let's plug in 1 into the original. So this is 1 squared minus 2 times 1 minus 15. Right, we just plugged it right back in. 1 squared is 1. 2 times 1 is 2 minus 15. So combining what we know, 1 minus 2 minus 15, -16. So the vertex is at 1, -16. All right. So let's see. -16. So these goes by 2, 3, 4, 5. They go by 1. So 1, -16. All right. The y-intercept, or actually dilation, would just be 1, right? It's the a value. The a value. The y-intercept is going to be -15. So here, that'll reflect across. Right? Immediately, it'll reflect across. And the roots. Okay. So a couple different ways of figuring this out. We can either A, factor this thing. If we try to factor it, that'll put us in this form, right? If we try to factor it. Can it be factored? Yeah, it can. So two numbers that multiply to make 15 that add up to -2. That's going to be 3 and 5. 3 and 5 somehow make a 2. So multiply to make negative. All right, so -5. 3 times -5 is -15. 3 plus -5 is equal to -2. So x plus 3, x minus 5. Those numbers drop right into the factors. So -3 right inside lies. So it's going to cross at -3, and it's going to cross at 5. And that should make sense, right? Because it's evenly spaced. It's centered at the axis of symmetry. All right, so what else do we need to answer? We just said that x equals, -3 and +5. Yeah. Domain, again, all real numbers. You might even see it like this. Or simply put all real numbers, right? And the range is going to be from the minimum towards infinity. So -16. So -16 towards infinity. -16 gets the bracket, and infinity always gets parentheses. All right, and this was definitely a min. Oh, you know what? I feel like maybe it wants the number. The minimum was at the y value, right? At y equals -16. Over here, this was going to be y equals 8. I have a feeling that's what they want. Okay. All right, so drawing this. All right, if you're wondering how I drew those, there's other videos about that. So just connect the dots. Okay. Good enough. All right, this is vertex form. The thing that we can see is that the vertex is going to be at 3, -1, right? Inside lies, outside tells the truth. So this is vertex form. 3, -1. So that's the vertex. It's in vertex form. It opens up because A is positive, right? That's a positive number outside. So it opens up. Axis of symmetry is definitely going to be on x equals 3, right? Because it goes through the vertex. The axis of symmetry always goes through the vertex, the x component. I don't even need to do any math. Vertex, we just said 3, -1. Dilation is 2. It's always the A value. It's always the A value. The y-intercept. This one. Okay, so there's two ways to figure this one out. We could either expand it out, or we could just let x equal 0. Remember, y-intercept is when x is equal to 0. So we got 2 x minus 3 squared plus 1 minus 1. Yeah. Okay. So again, the two ways we could expand out x minus 3, right? Square it, distribute the 2, subtract the 1, or we could just plug in x equals 0 right now. 0 minus 3. This is 2, 0 minus 3, -3 squared. So Right? It's PEMDAS. You can't distribute the 2 and then square it. You have to square the 2. You have to apply the square first. So this is 9 times 2 minus 1, which is 18 minus 1, which is 17. So the y-intercept is at 17. Is that going to make sense? No, it doesn't. Well, because it's not on the graph. That's what I'm saying. Right. There's a good chance it could be off the graph. I didn't make this, so. Okay. Domain, all row numbers, always all row numbers. The range is going to go, it's going to open up. So it's going to go from the vertex upward. So -1 towards infinity. And it's going to be a minimum, right? Because it opens up at y equals -1. All right, so let's catch up on the picture. So I know that it's going to open, or the axis symmetry goes through the vertex. The dilation was 2. So that means 2. All right, that's good enough. If you can do that, you'll be straight. So there it is. Okay. I have to watch those a couple times to figure that out. All right. 4, 5, and 6. This is going to be using a very specific method, the slide and divide method. All right. Slide and divide is nice when the number in front is a 1, because you really don't have to slide anything. You just come up with 2 numbers that multiply to make 20 that add up to 9. So 5 and 4. 5 and 4 add up to 9. 5 and 4 multiply to make 20. So everything checks out. So the factors are going to be x plus 5, right, because it's a positive number, and x plus 4, because this is a positive number. And these are our factors. Right, there's a difference between factors and roots, or factors and solutions. Right, these are the factors, the things that multiply to get the thing that they gave us. Okay. Again, a was 1. There's no need to divide, right? If we were to divide by 1, we end up with the same thing. So there's no need. There's no need. In 5, however, there's definitely a need, because this is not 1. So we have to slide that number over and multiply. Multiply. So this is going to be, this is basically x squared minus 15x plus 14. So now we got to come up with 2 numbers that multiply to make 14 that add up to 15. I always start with 1, really, no matter what. Actually, it needs to be -15. Okay, so 1 and 14 definitely multiply, but it doesn't add up to -15. That's positive 15. So we make both of them negative. And then those are our factors. X minus 1, x minus 14. All right, now the most forgotten about step, it's the divide part, right? Because this was the slide part, and now the divide part has to happen. You have to divide this number by whatever number you slid. So, and then you reduce when possible. So this is going to be x minus 7. And now 1 over 2 doesn't reduce. So what you have to do is you have to take this number and just move it up. Right, 2x minus 1. That would be the factor. So it just slides up. So it doesn't look weird. Okay. Again, those are the factors. 6. Let's try it again. So sliding over, we get x squared plus x minus 6, because 2 times 3. I'm multiplying by 2. Therefore, I'm going to need to divide by 2 here in a moment. All right. Two numbers that multiply to make negative 6 that add up to 1. 2 and 3. 2 and 3 somehow make a 1. Negative 3. So 2 times negative 3 is negative 6. 2 minus 3 is positive 1. No, it's not. Negative 1. So it's not that one. It's this one. Right? We put the negative on the wrong one. Negative 2 times 3 is negative 6. Negative 2 plus 3 is positive 1. So this is going to be x minus 2, x plus 3. These are the factors. Well, almost, because we have to divide. Right? Because we multiplied, like the slide part happens, and now the divide part has to happen. And this is going to be x minus 1. Again, 3 divided by 2 is not an even number. So 2x plus 3. Those are the factors. All right, page 1 down. Let's go. All right, these are all very mechanical, right? They're technique heavy. So we got to use it. We have to solve by using the indicated method, or the method that's indicated. Slide and divide. We just did it. Let's do it again. So 3 times 8, x squared minus 10x. 8 times 3 is 24. So two numbers that multiply to make 24 that add up to negative 10. So knowing your times tables comes in clutch, I think. So this is going to be, if you can't guess, just start with 1 and 24. Right, always just start with the 1, because sometimes that's the 1. Not in this case, but we need to make it to add up to a negative number. So the big one has to get the negative number. 2 and negative 12. Hey, look, that's it right there. 2 and negative 12. Right, 2 times negative 12 is 20. It has to multiply to make a positive number, bro. So that means both of them have to be negative. So it's not that one either. That makes negative 14. Negative 14. Okay, so it's not either one of those. Let's keep going. Negative 3, negative 8. Nope. Negative 6, negative 4. All right, that's the one. That's the one. So negative 6, negative 4 make negative 10. All right. X minus 6, x minus 4. All right, we have to divide. Always divide for the slide and divide method. So x minus 6 divided by 3 is 2. And then this doesn't divide evenly, so we slide, or we swing the 3 up. This is going to be 3x minus 4. These are the factors, right? In the last 3 problems, we wanted the factors. Here we're solving. So we got to go one more step. And inside lies. So here this is going to be x is equal to positive 2. And we could actually take the opposite of the factor. right? X would be equal to positive 4/3. Right, because what we're saying is 3x minus 4 is equal to 0. That's what we're trying to figure out. So you add the 4 to both sides and then divide by 3. So x is equal to 4/3, positive. So a couple different ways you could think about that, right? Depending on what you're looking for. We're looking for the roots, the solutions. So you just can't stop at the factors like we did in the last one. And the solutions are always opposite inside lies of the factors, right? That's what we teach, inside lies. All right, quadratic formula, the go-to, negative b plus or minus square root minus 4ac all over 2a. So a, b, and c. Just plug and chug, bro. So negative 7 plus or minus square root 7 squared minus 4 times 4 times negative 2 all over 2 times 4. Okay, simplifying, negative 7 plus or minus 49. Negative and a negative make a positive. 4 times 4 is 16 times 2 is 32. All over 8. Okay, 49 plus 32. 49. 79. 81. That's nice. So negative 7 plus or minus root 81 all over 8. That's going to be negative 7 plus or minus 9. Right, square root of 81 is 9 over 8. So our two answers are negative 7 plus 9 over 8 or negative 7 minus 9 over 8, right? That's what plus or minus means. So negative 7 plus 9 is 2, positive. 2 over 8, which is 1 over 4. So 1/4 is one answer. Or negative 16 over 8, which would be negative 2. That's our second answer. So 1/4 or negative 2. All right. Square root method. I like this one. That's when there's only one x and it's squared. So what we're going to do is you have to minus 32 from both sides first. Right? When you're first learning about quadratics, this is always the first instinct, but it's always the wrong instinct, right? Because we don't learn to solve using the square root method first. You typically do other things. But in the square root method, you definitely got to do that first. So we're going to get negative 1/2 x minus 2 squared equals negative 32. All right. The rookie mistake is to try and take a square root now. I mean, it can be done, but not when you're first learning because you're going to get confused with all the things that are happening in the front. So what you have to do is get rid of this first. Right, this meaning the negative 1/2. That has to go away first. So what I'm going to do is I'm going to multiply. The only way to get rid of a negative is to multiply by a negative. And then you take the reciprocal of whatever it is. So this is 1 over 2. So I'm going to multiply by 2 over 1. 2 over 1 is just 2. Right, I'm multiplying by both sides. Right, I can do anything I want to an equation as long as I do the same thing to both sides. So what happens is what we were expecting to happen on the left. Everything cancels. So this is going to be x minus 2 squared is equal to right-hand side positive 64. So now when we take a square root, this is x minus 2, right? Taking a square root, when the square and the square root match or meet up, like when they touch, it cancels each other out. That unlocks the x minus 2. Plus or minus, always plus or minus. Square root of 64, it's 8. So solving, we get plus 2 plus 2. So x is equal to 2 plus or minus 8. So 2 plus 8 is 10. 2 minus 8 is negative 6. Right, those are our two answers. 2 plus 8, 2 minus 8. All right, number 10. Again, square root method. First thing I'm going to do is add 104 to both sides. So we get 104 equals 26 x squared. Divide both sides by 26. This even number. 2, 4, 6, 8. Yep, it is. Should be 5. Or 4 rather, I'm sorry. All right, and then square root. X is equal to plus or minus 2. So either positive 2 or negative 2. All right, square root again. Okay, so they're like blessing us with these. This is kind of nice. First thing I'm going to do is subtract 4. You always isolate the x squared term. So this is going to be negative 4 equals 49 x squared. Okay, getting the x squared by itself, got to divide by 49. So x squared is equal to negative 4 over 49. Okay. Square root. X is going to equal. So first off, it's plus or minus the square root of negative 4 over 9. The negative is going to come out as I, right? Anytime there's a negative under the square root, it immediately comes out. And then you just handle it. It's 49. You handle the square root as usual, as normal. So this is going to be plus or minus square root of the top, square root of the bottom. Square root of the top, 4. Square root of 4 is 2. Square root of the bottom, square root of 49, 7. Then I. So the answer, plus or minus 2/7 I. 2 over 7 I. That's it. 12. All right, again, the square root method. Let's go. So minus 10 to both sides. X plus 3 squared equals negative 10. All right, square root. So x plus 3 is equal to plus or minus. It's going to come out as an I. The negative, that is. All right, square root of 10. Square root of 10. That's 2 and 5. So you can't break it down anymore. So the square root of 10 is just the square root of 10. And the I goes outside. Some places, they put the I in front. It doesn't matter, right? Front, back, side to side. It don't matter. Wherever the I is, that's where it's at. It means the same thing, no matter where you put it. All right, so this is going to be minus 3, minus 3. So x equals negative 3 plus or minus 10i. Now, if the 10 had the part under the square root been a different number that could be broken down more, then we would have done that, but there's no need. There's no need. Okay. All right. 13 through 18, not decimal form, so no calculator on this one. We just have to simplify completely. And then all answers should be in radical form. All right. So 13. It's like how do you even solve this? The whole point is that there's a square root in the bottom. We don't like square roots in the bottom. So you have to do something to get rid of it. And the word is conjugate. So I have to multiply this by something that has a square root in it, particularly square root 3. It's going to be 2 plus. Right? It's always the same numbers with the opposite symbol. So this is called the conjugate pairs. Right? They're the exact same numbers, just one's plus and one's minus. All right. And again, it has to be top and bottom. Right? Because anything over itself is 1. Right? This figure on the right, this is just 1. Right? I'm multiplying something by 1, and I'm not changing the actual value. I'm just changing the way it looks. So the way we multiply this, the top is easy. We distribute. So 2 times 3 is 6. 3 times root 3 is 3 root 3. Don't be a rookie and say 3 times 3 is 9, right? 3 times 3 may be 9, but this isn't 3 times 3. This is 3 times root 3. And words have meaning, right? It's root 3. So 3 times root 3. Over. All right. To do the bottom, this is very particular. So 2 times 2 is 4. And then negative root 3 times positive root 3. Right? When you have conjugate pairs, you can multiply a very specific way and it's okay. It's going to be a negative root 3 times root 3 is just 3. Right? It would be 3 times 3 in this case would be 9. So the square root of 9. Square root of 9, 3. All right. Simplifying, we get 6 plus 3 root 3 over 4 minus 3, which is 1. That's nice. Because so that's basically it, right? That's basically it. I mean, you don't necessarily ever write over 1 ever. So this is really this. If it was multiple choice, you'd probably see this answer. 6 plus 3 root 3. All right, 14. Okay. Let's do it like this. So we're multiplying square roots. So we're multiplying the inside times the inside. So just combining it into one big square root, we're getting, so if you want, you can multiply 7 times 14. I'm just going to put 7 times 14. Like you could actually put the number, but it's not going to really make sense to actually multiply it because you're going to have to break it back down anyway. All right. And then this is going to be x to the 5th times x squared. So what I'm saying is, to simplify this, 14 comes down to 7 times 2. Right? Had you took time to multiply out, like I'm really wasting time by talking, but if you took time to multiply it out, 7 times 14, you're going to get some larger number. And then that number is going to get broken down into 7 times 14, and 14 is going to be 7 times 2. So, right, like there's no need to multiply. All right. So the pairs come out. So a 7 is definitely going to come out. And then a 2 is going to get left behind. Because it doesn't have a pair to bring out. Okay. X to the 5th and x squared. In total, there's 7 x's, right? There's 5 on one and 2 on the other. So there's 7 x's total, right? When you multiply common bases, you add the exponents. 5 plus 2 is 7. So really, there's 7. And we take out all the pairs. So there's an x, there's another x, and there's another x. So there's 3 x's that come out. And then there's 1 x that stays behind. Right? Anything that comes out of the square root in pairs gets multiplied. All right, you might have to watch that one a couple of times to understand what happened. Okay, 15. So here you have a square root and a fraction. Fraction inside of a square root. We take the square root of the top, square root of the bottom. Individually. Oops. Right. The whole point is that we don't want a square root in the bottom. Like that's the whole point, right? Like, and we don't want a fraction. So we have to get rid of the square root in the bottom. Again, the thing that we're going to multiply by is whatever's in the bottom. So root 11 times root 11 is just 11. Right, it's just 11. It'd be 121. Square root of 121 is 11. All right, and then up top we have the square root of 66. That's the answer. Right, because 66 can't get broken down anymore. 6 gets broken down into 2 and 3, and 11's a prime number. So there's no way to break 66 down. All right, 16. Speaking of breaking numbers down, so square root of 150. There's multiple different ways of doing this. You could use prime numbers, doubles. Either way, I like using prime numbers. I like starting with 2, right? Like I'm actually better, but in explaining it, right, it's best to just start at 2 and then just kill it to death with 2 until you start to realize that you can use bigger numbers. But like, there's no shame in just doing it this way. And even if there is, I don't care. So this is going to be 3 and 25, 5 and 5. Right, 2 times 75. 75 is 3 times 25. 25 is 5 times 5. So the only pair I can bring out is 5. Square root of all the singles left behind multiplied. So it's going to be 6. Okay, 5 root 6. All right, 17. Now we're adding and subtracting square roots. So the only way you can do that is if the part inside the square root match, right? Here they don't match. 175, one's 48, one's 243. However, if we start to simplify each of these, then eventually we'll come into maybe ones that do match. So 75 is really 3 and 25. 25 is 5 and 5. So a 5 is going to come out. 3 left behind. 48 is 2, 24, 2 and 12, 2 and 6, 2 and 3. So the pairs here, 2, another 2. So a 2 is going to come out, then another 2 is going to come out, and then those 2's multiply to make 4. 2 times 2 is 4. 3 is left behind. And then lastly, 243. Okay, so 2's not going to work. 3 will work. Okay, so 3 goes into 24. 8 times 1. Oh, that's nice. 9 and 9. So I'm going to actually just stop here. 9s aren't prime numbers, but they're doubles, and I'm okay with that. So 9 will come out, and then root 3 will be left behind. Okay, So now that we've rearranged, or not rearranged, reconstructed, I guess you could say, or simplified the radicals, we see that they all have the same label, right? Root 3. They all match. So this is basically going to be 5 plus 4 minus 9. Right? 5 plus 4 minus 9. That's crazy. 5 plus 4 is 9. So 9 root 3 minus 9 root 3 is 0. That's mean. We did all that work for it to be 0. Okay. 18 is the same way. Well, it's similar. We're multiplying. And it's going to be outside times outside and inside times inside. However, inside times inside is going to be crazy, right? It's 24 times 50. That's going to be a pretty wild number. So something you could do is just simplify first. That might be better. 2 and 12, 2 and 6, 2 and 3. So here, the pair of 2s is going to come out. But there's already a 2. So that's just going to multiply. So 2 times 2 is 4. And then root 6 is left inside 2 times 3. This is going to be the next one. 2 times 25, 5 times 5. So a 5 is going to come out. But there's a 4 outside. So it's going to multiply against negative 4. So 5 times negative 4 is negative 20. And then 2 is left inside. All right, so now that we simplified, now let's go back and do the original thing that we were going to do. Outside times outside, inside times inside. So outside times outside is negative 100. Inside times inside, 6 times 2 is 12. Okay, the last step is to always make sure that you can simplify the inside, which we can. This is going to be 2 and 6, 2 and 3. So this 2 is going to come out. So negative 200 root 3, right? Because the 3 is left over. Okay. Page 2 down. Let's go. We're almost there. My goodness. All right, 19. I, complex number. Okay, so the list goes I, negative 1, negative I, 1. And I know that it goes I1, I2, I3, and I4. And it's going to repeat. It's going to repeat this cycle overs and overs and overs and overs. What number is closest to 69? That's divisible by 4. Probably, let's see. Well, I know 8 times 20 is 80. 8 times or 4 times 15 is 60. Okay, I like that one. So what I'm saying is I don't want to sit here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like until I get to 69. If you go to a number that you know is divisible by 4, that's close to 69, that works also. So what did I say? 60? Because 4 times 15. So I know that 60 is going to be right here. I to the 60th power. And that helps us out because if that's 60, then this would be 61, 62, 63, 64, 5, 6, 7, 8, 9. So 60, I to the 69 power is just I. Now, did you have to do it that way? No. The other method is to take the power and long division by 4. 4 goes into 6 once, and then 4, 2, 9. 4 goes into 29 7 times, 28. Subtract, we get 1. So this would be the power we look at. Always look at the remainder. The remainder. Right? 1. So it would just be I. So those are the two ways. There's nothing wrong with counting, right? Like, don't forget that you know how to count. Counting works just as good. Okay. 20. Same idea as before. This comes out as an I. So right away we get negative I root 188. So I put the I in the front this time. Like I said, it doesn't matter. Now we just break down 188. 2 into 94. Right, half of 18, half of 8. This is going to be, again, 2. So half of 90 is 45. Half of 4 is 2. 47. 47 is a prime number. Lucky us. Okay, so the pair of 2's is going to come out. So we get negative 2i root 47. Right, knowing it's a prime number is clutch because otherwise you're in the calculator trying to figure out what number divides into 47. You're going to go through all the numbers to find out that only 47 and 1 are the only things that work. All right, 21. We're adding. So all we're doing is combining like terms. Adding 3 plus 5 is 8. 2 plus negative 7 is negative 5. Right, adding is nice. So just if that wasn't there, it'd be multiplication. But there's a plus there. And symbols definitely mean things. Right? Symbols have meaning. Just like this one. This is subtraction. So now there's two ways to think about it. You could say 7 minus 3, which is 4, and 6 minus 8, which is negative 2. Right? But you got to be careful because if there's other negatives in here, then it's a good chance you'll make a mistake. So the preferred method is to just distribute. This would make negative 3 minus 8i. And then you just combine 4 minus 3, or I'm sorry, 7 minus 3 is 4. 6 minus 8 is negative 2. But you can do it either way. Like, I just like to get to the answer as quick as possible. All right, 23. Here, a couple things are happening. One, we're going to distribute first and then combine all the like terms. Right. So this is going to be 4 times 5 is 20. 4 times negative 2, negative 8i, plus 6 times 3, which is 18. 6 times negative 9, which is negative 54i. And now we combine the things that are alike. 20 plus 18 is 38. And then negative 8 minus 54 is negative 8, 9, 10, 11, 12, 62. Okay. 24. All right, so these two are completely different, right? This one's 23 was addition and then combine. 24 is just straight multiplication. So we have to FOIL this out. Right, FOIL, that's the first, outer, inner, last. So first, 2a times a is 2a squared. Outer, 2 times 6, 2a times negative 6i is negative 12ai. Inner, 5i times a plus 5ai. And then last, positive times a negative is a negative. 5 times 6, 30, I squared. Combining like terms and changing I squared. So this is going to be negative 12 plus 5. Negative 7. So 2a squared minus 7ai. I squared is negative 1. That's going to change the symbol in front to a positive, right? Because negative times a negative, right? This is negative 30 times I squared, which is basically negative 30 times negative 1, which is basically plus 30. Can't combine anymore, so we're going to leave it at that. Okay. 25. Same idea, just with an x. So x times 6x, 6x squared. X times 2i plus 2xi. Negative 5i times 6x is negative 30xi. Negative 5i plus negative 5i times 2i is negative 10i squared. Combining the things that are alike, 2 minus 30, negative 28, minus 28 xi, and then I squared, of course, negative 1, so it just changes the sign to plus. Okay. So here, definitely simplify first, right? Because I don't want to do 128 times 32 and then start figuring out whatever. So this is going to be first things first. Negative always comes out as an I. Negative always comes out as an I. So far, the things that are outside get multiplied. 5i, negative I. All right, so this is going to be negative 5i squared. Okay, that's outside. I squared is really negative 1. Do we want to handle it now? Are we capable of saying that this is negative 1? So negative 5 times negative 1 is just positive 5. Okay, positive 5 it is. I'm saying we either do it now or we do it later. Let's just get it out the way. So 2 times 64. Right, I'm breaking down 128. 64 is 8 and 8. I know that because it's a perfect square, right? And now the pair can come out as a single 8. Anytime something comes out as a single 8, it gets multiplied by whatever's outside. And right now there's a 5 outside. So I'm just going to write it right here. But I don't want to lose you. So let's just leave it right there. All right. Inside the square root is a 2. All right. On the right-hand side, 32. 32 is 2 times 16. 16 is 4 times 4. There's my pair. A 4 is going to come out, and a 2 is going to stay behind. All right, and all this is being multiplied. So what happens is all the numbers that are outside are going to get multiplied. So 5 times 4 times 8. 5 times 4 is 20. 20 times 8, 160. Inside times inside. 2 times 2 is 4. Okay. Square root of 4 can be simplified into 2. So this is going to be 160 times 2, which is 340. Is that right? 0, 6 times 2 is 12. Carry the 1, 320. Wow. 320. All right, 27. Write the equation in standard form given the roots -2, 0, and 5, 0. Okay, so what this is telling me, they're giving us the roots. Remember what roots mean. The x-intercepts, right? It's where it crosses the x-axis. So that means x is equal to -2 and x is equal to 5, right? Because that's where they cross, right? When x is -2, y is 0. -2, 0. So x equals -2. That's the root. And same argument for 5, 0. All right, so these are the roots. All right, roots turn into factors. Inside has to lie. So it has to be x plus 2 and x minus 5, right? These are the roots. These are the factors. All right, this is relevant because we're going to FOIL this out to get something in standard form. So x times x is x squared. X times -5 is -5x. 2 times x is 2x. 2 times -5 is -10. Combining the things that are alike, x squared minus 3x minus 10. So this is standard form. Right, standard form is like that. Just remember that when they give you the roots, make them x equals whatever the roots are, and then turn the roots into factors. All right. Solve the following quadratics using the quadratic formula. All right, let's go. Quadratic formula. I'll write it off to the side. And this review's kind of all over the place, huh? Okay, so A, B, C. So B is -4. So they try to do this to you, right? Because it's -B, but B is -4. So it's got to be negative, right? This negative is part of the formula. And then this -4 is because B is -4. Plus or minus square root -4 squared minus 4a, which is 3, c, which is 2, all over 2a. Right, notice everything in red came from the equation, and everything in blue came from the quadratic formula. We just plugged in the appropriate values. All right, so negative times a negative, +4. Plus or minus 16, right? 4 squared. Minus 4 times 3 times 2. 2 times 3, 6. 6 times 4 is 24. All over 2 times 3, which is 6. Okay, 16 minus 24 is going to be 4 plus or minus the square root of -8 over 6. All right, so this isn't that bad. Just remember, negative always comes out as an I. And we can simplify 8. 2 times 4. 4 is 2 and 2. Here's my pair. That stays behind. So almost to the final answer, we get 4 plus or minus. The 2 comes out. The I comes out. √2. All over 6. Okay. There's very well a good chance that this could be an answer on a multiple choice test, right? Like they try to they try to trick you to see if you really understand. I mean, it's kind of mean because here we are at the answer, but the answer they're going to be looking for is they want to see if you are clever enough to see that these can be simplified. The rookie mistake is to just go like this. Right? You can't do that. You got to take away from all three terms. Right? I'm taking a 2 out of everything. So, final answer. 2 plus or minus I root 2 over 3. Which you might even see it like this. So this is both ways. Right? They mean the same thing. You could actually split up the denominator. Put the denominator under each number. I mean, they're all equivalent answers, right? So it truly doesn't matter. Okay. Number 29. Hint, rewrite in standard form. Okay. So if I standard form meaning we want everything on one side. So this is 3x squared plus 42x plus 24 equals 0. Okay, first thing I realize is that if I try to use quadratic formula right now, it's gonna suck. Like there's no other way to put it. However, if we divide everything by 3, because we notice that all these numbers are multiples of 3, it's gonna make life a little bit easier. So x squared 42 divided by 3 is 16. X 24 divided by 3 is 8. 0 divided by 3 is 0. Okay, now this is way nicer. Way nicer. Because now when we use the quadratic formula, this is my A, this is my B, and this is my C. I mean, it still isn't really nice because 16 squared, we have to figure that out. But, I mean, if you know it, you know it, right? So this is going to be negative B, so negative 16, plus or minus 16 squared minus 4 times A times C, all over 2 times A, which is 1. So I'm not going to write 1. All right. 16 squared is 256. Oh, look, I'm tripping. I wrote A. A is just 1. My bad. All right, so this is going to be negative 16 plus or minus square root 256 minus 8 times 1 times 4, 32. And over 2. Okay, 256 minus 32. It's going to be 226 minus 2, 224. Negative 16 plus or minus root 224 all over 2. Okay, so the only real work is this 224 business. So 2, 11, 12, 2 and 56, 2 and 28. Oh, you can't see it. 28 is 4 and 7. I mean, I could have used 2 again. Hopefully I didn't confuse anyone. 4 is 2 and 2. Okay, so look what's happening here. We have a pair. There's a 2. Here's a pair. There's another 2. What's left behind? 2 and 7. So what we're going to get is negative 16 plus or minus. A 2 came out, a 2 came out. So that's going to mean 2 times 2 is 4. Square root of 2 times 7, 14. All over 2. All right, we have 3 terms. 2 on top, 1 on the bottom. So they're all even. So we can take out a 2 from everything. This is going to be 8, and this is going to be 2. So final answer, 8 negative plus or minus 2 root 14. 14 can't be broken down, 2 and 7. Okay, we're definitely over an hour. We're almost done. Oh my God. Okay, so use the completing the square method to change each quadratic equation into standard form to vertex form and state the vertex. Then solve the equation for x. Okay, so here's where methods, basically it comes down to technique. How I do it is may not how you were taught or seen before, but watch. It's gonna be the same thing, I promise. Okay, so I move the 12 first. Now a lot of people don't do that, but whatever. Okay, I like completing the square like this. Move the C to the other side. Otherwise, you got to do like crazy things. All right. So I'm going to take half of B. Right, B is negative 8. So half of negative 8 is negative 4. Okay, negative 4 is a very important value. Negative 4 is going to show up just like that. All right, I have to square it. Negative 4 squared is 16. That's the number that I add to both sides. So notice what happened. You took half of B. That number shows up immediately into the factor. And then when you square the value negative 4, that's the number that you add. All right, so what happens is this whole left side is guaranteed to factor into that x minus 4 squared. Then on the right-hand side, negative 12 plus 16. So this is going to be 4. So what happens, right, you have to have a very good understanding, not a very good understanding, but it has to be explained to you, like, what's going on. A very good understanding of quadratics. So what's happening is that if I move the 4 back over, all right, this is basically the vertex form right here. And the vertex is going to be 4 comma negative 4. Oh my goodness, there was blanks. Okay, so vertex form is negative x, or x minus 4 squared minus 4. That's the vertex form. Vertex we said was 4 comma negative 4. Okay, the roots. So let's solve for x. The roots are going to be, if we solve for x here, really, if you solve for x here, this is, right, this is going to be So if I solve for x, I'm going to get x minus 4 plus or minus 2, right? Because the square root of 4 is 2. And if I add 4 to both sides, I'm going to get x is equal to 4 plus or minus 2. 4 plus 2, 4 minus 2. So x is equal to 6, 2. All right, 4 plus 2 is 6. 4 minus 2 is 2. All right. So completing the square and vertex form and all this other nonsense, it's I don't know, it's a matter of technique, right? Like the way I do it, I know how to get to the vertex form. That's the way I pretty much showed people that I deal with. And then the vertex is identifiable, and then I can just solve for x's. So this is x equals 6 and 2. Those are the roots. Okay. Let's try it again. Here, what's different about this is that a is not 1. Right? When a is not 1, more steps have to be taken. So I can't complete the square unless a is 1. So the fastest way to do that is to just divide everything by 2. And look at the part that's going to suck, right? 17 over 2. That's already like giving me a headache. So this is going to be x squared plus 12 divided by 2 is 6x minus 17 over 2 is equal to 0. All right. First step, technically we already did the first step. Next step would be to add the 17 over 2 to both sides. So we're going to get x squared plus 6x is equal to 17 over 2. All right, now we can complete the square. So this is going to be, first I got to take half of b. B is 6, so I take half of b. That's going to be 3. All right, I've already trained myself that when I take half of this number, this is an extremely, extremely important value, right? This number will show up here, right? It just does. Like, it's part of the process. All right. The next step, like the second part of this, you have to square this number. When you square it, you get 9. That's, look, so when you square it, you get 9. 9 is the next important value. That's going to be the number you add here and here. I already know that no math happens on the left. It's going to immediately factor into that, right? It does. And then 17 over 2 plus 9. Okay, here you might not like this part because it's dealing with fractions, but I promise if you just think about it logically and then one little trick, it's not that bad. 17 over 2 plus 9. All right, yeah, you can get a common denominator, yada, yada, yada. Or if you add these two together, you're going to get 9 and 17 halves, right? That's what it is. It's a mixed improper number, right? And then there's a little trick to turn this into an improper fraction. At the end of the day, we need an improper fraction. This would be 9 times 2 is 18. 18 plus 17, right? 9 times 2 plus 17. This will give us 9 times 2 is 18. 18 plus 17 is 35. Okay. So what this is saying is that x plus 3 squared is equal to 35 over 2. Take the square root. X plus 3 is equal to plus or minus square root of 35 over the square root of 2. Now, do I want to rationalize the denominator now? Right, square root in the bottom is bad. That's why I split it up like that. So this is really, and we're almost there. So this is, so x plus 3 is equal to plus or minus the square root of 70 over 2. 70 doesn't break down, right? Because 35 is 5 times 7. 70 is going to be 5 times 7 times 2, all prime numbers. So 70 won't break down. It seems like it would, but it won't. All right, minus 3, minus 3. So right now what we're solving for are the zeros, right? This is going to be x equals negative 3 plus or minus root 70 over 2. So x equals negative 3 plus or minus root 70 over 2. I don't care if they want a different answer. That's my answer. All right. So the vertex and vertex form. So it's kind of like backtrack a little bit. Vertex form, can we identify it? Yes. It was right here. Basically, it's right here, but before the square root part. So vertex form would be x plus 3 squared minus 35 over 2 equals 0. This would be the vertex form, right here. And then the vertex would be 3, negative 3, comma, negative 35 halves. That's kind of mean that they make it to where it doesn't work out nicely. 2 times 9 is definitely 18. 18 plus 17 is 35 because 18 plus 18 is 36. Minus 1 would be 35. So yeah, no, let's just rock with it. All right, that's what it is. Okay, 32. We're almost done. Let's graph this inequality. Okay. First thing I notice is that it's an intercept form, and I know how to deal with intercept form. I know what intercept form is telling me. Intercept form is telling me that this crosses the x-axis at negative 4, and it crosses at positive 2. I know it does that. And then I know it opens up because the number that's in front is positive, right? There's no negative, so it has to open up. Next thing I realize is that, okay, it's going to be the axis of symmetry has to be exactly in the middle. It has to be exactly in the middle, right? So 3 left and 3 right. And it opens up. So what I need to do is figure out where's the vertex on this line. So the vertex. So if we consider for a moment, so this is x equals negative 1. So if we just consider what we get when we plug in negative 1. 3 times negative 3, which is negative 9. So that means bro, who makes these? So this is going to be negative 1 plus 4 is 3. Negative 1 minus 2 is negative 3. 3 times 3 is 9. So, like, we don't even have enough graph to do this on. So this is going to be down here. And start graphing. Right. All right. So, in fact, it needs to be a dotted line. So it needs to be a dotted line. So I can cheat a little bit. We'll just make it dotted. All right, it's dotted. There you go. All right. I need a shade on one side or the other. So it's my recommendation that if we test the point 0, 0, x equals 0, y equals 0, and see if we have a true or false statement. If I plug in 0, 0 and it's true, we're shading definitely on the side that contains 0, 0. If we're plugging in 0, 0 and it's false, then we're definitely shading on the opposite side, the side that doesn't contain 0, 0. So what I mean is, this is going to be 0, this is going to be 0, and this is going to be 0. So we're getting 0 is greater than 4 times negative 2. So 0 greater than negative 8. Is 0 greater than negative 8? Yes, 0 is bigger than any negative number. So this is true. So that means we shade on the side that contains 0, 0. So 0, 0 was inside of the parabola. So everywhere in here except for, well, just everywhere in here. Right, and like the graph goes on forever. So there it is. Anywhere that is in blue is going to be a solution. Right, this goes on forever. Okay, let's try it again. This is in standard form now. It's okay. We know how to handle this. So just at a glance, negative 4, right? This is the y-intercept. So I know it crosses at negative 4. I know it does. Also, I know it opens up. So let's figure out how does it open up. So negative b over 2a. This will give us the axis of symmetry. So negative, again, negative 3. Just super mean with it. 2 times a, 1. So negative times a negative, positive 3 over 2. So 3 halves, positive 3 halves, 1.5. Okay, 1.5 is going to be here. So the axis of symmetry goes through 1.5. Not only that, it's going to be reflected. The y-intercept is going to be reflected across the axis of symmetry. And now, if we plug in 3 halves into the original, we can figure out where the vertex actually is. So this is going to be 3 over 2 squared minus 3 times 3 over 2 minus 4. Okay, they were not kind with this at all. So this is going to be 9 over 4 minus 9 over 2 minus 4. Right, square the top, square the bottom. 3 squared is 9, 2 squared is 9. Minus 3 times 3 over 2. So top times top. 3 times 3 is 9 over 2. Minus 4. Okay, let's see. I'm going to do some mental math because it's getting kind of late. So this is 18 over 4 minus 4. Basically 16 over 4. Okay, so doing this, we're going to get 9 minus 18 is negative 9. Negative 9 minus 16 is negative 25. So negative 25 over 4. That's ugly. Is that true? Usually when it starts to get ugly, it's because I made a mistake. But no, negative b over 2a. Yeah. I mean, even if I factored it, that would give me the 3 and 1. No, it wouldn't. Anyways, all right. So negative 25 over 4. What's that? It's not quite 6. So 5 something, 5 point something. 5 point something. Let's just roll with that. So 4, 5, it'd be down here. Okay. I mean, that's just not right, right? All right. So do I really want to figure? All right. So it is a solid line because it's or equals to. All right. And I don't think it goes through 4. Like I'm trying to get that correct, but it's gonna be close. It's gonna look like that. All right. The important part is that 0, 0 is highly identifiable. And we're gonna see, do we shade inside or do we shade outside? There is a little trick that if you look to see, oh, is the number less than or like whatever. If you plug in 0, 0 every time, it'll never lead you wrong. Right? Plug in a 0 for everything. So we get 0 is less than or equal to negative 4. Is that true? Is 0 less than negative 4? No, it's not. That is false. That's super false. So then that means we shade outside. Okay. To the back. 34. This is standard. Not standard. This is vertex form. Vertex form right away. So we see that the vertex form is negative 2, comma negative 5. That's where the vertex is going to be at. So negative 2, comma negative 5. I know Axis of symmetry goes through that joker. And I know that that's all I know. Okay. Actually, I know more. So the dilation is 3. That's going to tell us that the next points are 3 up. And then 12 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. The drawing may not be precise, but it's definitely accurate. Okay. And then 0, 0 is outside. So let's test 0, 0. Remember, if it's true, we're shading on the side that has 0, 0. So this is 0, 0. So 0 greater than 3 times 2 squared minus 5. This is going to be a positive number. So 2 squared is 4. 4 times 3 is 12. Minus 5, 7. Is 0 bigger than 7? No, it's not. That's false. So we shade opposite of where 0, 0 is. All right, 35 is a fun one. We have to graph 2 things. And they give us a hint. So first off, this one, the top one, the quadratic with the square, the vertex is going to be at 3, 2. It's going to open down. So let's do that. 3, 2. Axis of symmetry. Dilation is 1. I assure you that's where the dots go. There's definitely a trick. Like, it's almost magic. Is it a solid line? It is. Thank you. Okay. And then 0, 0 is outside. So when I plug in 0, 0, zero less than negative 3 squared plus 2. So negative 9. Right, negative's outside, so that stays. Negative 3 squared is 9 plus 2, negative 7. So is 0 less than negative 7? No, it's not. That's false. So what that means, that means that we have to shade opposite of where 0, 0 is. Right? 0, 0 is outside. It's false, so I have to shade inside. Okay. I think that's good. All right. So that's the one. Now the other one is a linear. So if I just minus x, I'm getting y greater than negative x, negative 3. And if you think back to algebra 1, we know that the b is negative 3, and that's where it crosses the y-axis. And then the slope is negative. So it's going to go down 1 to the right. Not only that, but it is strictly greater than, so it gets a dotted line. Now, you could do your little trick because it's greater than and shade on whatever side, Or just plug in 0, 0, like it never fails. Like I don't understand, right? This is 0 greater than -3. Is 0 greater than -3? Yes, it is. All day it's greater than. 0 is bigger than any negative number. So that means I'm shading on the side that contains 0, 0. So then this means that the overlapping part, you can't see, the overlapping part is the solution. The overlapping part. We have a solid line. And then we have a dotted line. And then everything in between. There it is. That's the solution. Okay. Solve the inequality. All right, this is basically what we just did, except without the graph. Without an actual graph, we are going to just make a number line. All right, so first we try to factor. What numbers multiply to make 8 that add up to 2? -8 that add up to 2. So just 1 and 8. But it needs to be negative. So one of them needs to be negative. But when they add up, they have to add up to a positive number. So that means the small one's going to get the symbol, the negative. Okay, so that doesn't add up to 2. Oh, here we go. -2 and 4. So that means x minus 2, x plus 4. Which means, right, these are the factors, but this means x equals 2 and x equals -4, right? Inside lies, you always turn factors into roots. And so the number line graph, -4 is on the left, 2 is on the right. All right, 0 is going to be somewhere in here. Not only that, but it's going to get a closed circle because it's or equals. Closed circle, or equals. And we test 0, 0. Or we just test 0 rather. This is going to be 0. This is going to be 0. Is 0 greater than or equal to -8? Yes, 0 is definitely greater than all negative numbers. So that means I'm going to shade on the side that has 0. So the answer is going to be the inequality. You can't see it. X has to be between -4 and 2. And it's closed circle. Right? Right? That's what this is saying. Right? If you give me an X, that'll make this true. So what X can I plug in that would make the right-hand side smaller than 0? Well, any of these X's. Any of these numbers that are strictly in between -4 and 2, right? 1.9999999 will work. However, 2.00001 will not work because it's outside the interval. That's what this is saying. So -4 less than or equal to x less than or equal to 2, right in between. This is the inequality. Okay, here we are. We've arrived at the last problem. Solve the inequality. Hint, rewrite so that x squared is positive. Okay. I agree with this hint. Right. X squared, when it's positive, life is just better, right? Because it's less thinking. Things behave the way it looks. So I'm just going to move everything to this side and then do what we just did up here. Right, I'm going to move everything and do what we just did. So this is going to be x squared plus 2x minus 3 greater than or equal to 0. Something tells me this one's going to be ugly. All right, two numbers that multiply to make -3 that add up to 2. 1 and 3. Okay, that's not bad. That's not bad. So this is going to be, does it add up to 2? Yeah, I do. So x minus 1, x plus 3. Okay. 2 tick marks. X equals 1, x equals -3, right? Inside lies. So we'll make this -3. We'll make this 1. It's or equals, greater than or equals. So close circle, close circle. And then 0 is always in between positive and negative numbers. So when we test 0, what happens? 0, 0. Is -3 greater than 0? No, it's not. -3 is not greater than 0. So that means we shade in the other side that doesn't contain 0. Right? These two go together. So the inequality for this answer, it's going to be 2 pieces, right? Because when the graph has 2 pieces, right, this is going to be -infinity up to -3 bracket. Oh my goodness, inequality, not interval. So x has to be less than or equal to -3, or x has to be greater than or equal to 1. All right, there it is. If there's any mistakes, my bad. Leave in the comment and let me know what I did wrong, or let me know what I did right. Good luck, guys. Catch you guys in the next video.